This is Chapter 4, Part 2, dealing with heat loss computations. And in this instructional video, I'd like to review some of the topics in the chapter that deal with below grade or on grade construction and the insulation value. Earth can be a very good insulator to the building. And as you can see in this slide, at about 1 foot of dry earth has an R value equal to 1. But as you go down in below grade, the earth actually has a lot of temperature changes from above grade. So in the second bulleted item, you can see the earth temperature being about 50 degrees or so below grade. And it depends upon the location, but what this does is cut down the temperature differential. So like on a very cold day where it's like 20 degrees outside, basically the wall that is exposed to the earth is exposed to 50 degree temperature rather than 20 degree temperature. And therefore they've got some charts in this chapter that are going to deal with how this helps the heat to reduce heat loss. So there's basically this soil acts as a storage unit for energy for heat, and it creates kind of a thermal lag from the changes that exist above grade. So in this case, over to the right, you'll see the 8-inch concrete units, or CMUs, that are here, and then you've got like a 2-inch rigid insulation, and there'll be some furring strips on this surface as well. So what is done in the chart is they've modified the R value. So if you look up at the top here, this is a R 4.2, which would give you about a U of 0.23. So as you go down into the earth, the U factor for this wall actually gets better and better. So this chart is giving you the U factor as you move down into the earth. So in my example here, you're 4 foot down into the earth, and when you're 4 foot down into the earth and you've insulated your wall with rigid insulation to get a 4.2 R factor, you will have a 0.079 U factor. So in this case, the U is equal to 0.079 rather than a 0.23 U factor if it were not below grade. This is quite a significant benefit to the consumer in this system of construction. So they're showing you on this slide how below grade and the U factor will improve the lower you go. Now one of the controlling factors is for a basement. Right along here we typically put a window. So unless you're going to put a window well, it's hard to get distances much more than about 4 or 5 feet below grade. The next topic I'd like to talk about is transmission of heat loss through a slab. Most commercial buildings are built with a 4-inch concrete slab on grade, so you can just kind of walk into the building without going up steps, in contrast to a residence, which typically you have a crawl space. So what we have is we have a concrete slab, very handy for people to access the building. And so what we are considering is really the exterior perimeter of the slab. So if you look at an existing room, see if I can get to one of these. In this room right here, the loss to the slab is only through the exterior wall. So there is no slab loss through this middle space in the slab. It's only around the perimeter of the room. So I flip back up here, and so what they've done is they say if you have 1-inch insulation around the perimeter, then if your outside design temperature is like 14 in Richmond, you would go across here and you'd slide over and you'd have a U value of a U of 40. And so what you're going to do is take that F factor of 40 and multiply it times the length of the room. So what this is giving you, sometimes referred to as a F factor, is 40. So if I go down here, you'll see this is the rigid insulation. And so the heat in this rigid insulation protects the interior space from heat transfer through this wall. So basically what we're saying is the heat goes like this, or the cold, and over here to the far right is very little heat transmitted out of the building. It's only around the perimeter, so they can run the slab insulation in either an L shape or vertical shape or all horizontal shape. But by and large, you'll probably see a more all vertical shape, but it depends upon the condition of the construction. So in this case, we're going to take the 1-inch insulation, we'll get the perimeter, it will be 26 feet times the R value of 30 if we have 2 inches or R5 insulation. So this chart's basically developed about 2 R values for perimeter insulation or thickness of insulation and the outside design temperature.